Singularity.
My name is Nicola, aka Socrates, and you're watching Singularity One-on-One. Singularity One-on-One is a regular podcast feature of Singularity weblog where you can go and listen to it or download it in full. If you guys enjoy this show, you can help me make it better by clicking the like button on YouTube, by sharing this video, by writing a brief review on iTunes, or by simply making a donation. As always, I will be the man with the questions, and today the man with the answers is Daryl Oster, the man who wants to bring frictionless space travel on Earth that will be cheap, 4,000 miles per hour fast, and accessible to everyone. Daryl is the CEO of Evacuated Tube Transport, which is a very interesting company pursuing an amazing idea that I only discovered recently in the last few days during the fantastic Idea City conference in Toronto, Canada. So without further ado, welcome Daryl. I'm so happy to have you on my show.
Thank you very much. It's a pleasure.
So Daryl, if you were to introduce yourself in your own words, how would you do that?
I'm an inventor and I'm a founder of ET3 Global Alliance.
Fantastic. So let us start first with your company, ET3. What does it stand for and what is the company's goal or mission statement?
ET3 stands for Evacuated Tube Transport Technologies. Those are the 3 T's. And our vision is being able to travel from here in Toronto to Beijing, China in 2 hours at about a tenth of the cost of flying. Or for cargo to move a pallet at a time from any manufacturer in India or China to any strip mall in North America, a pallet at a time minimum order in 4 hours instead of a whole shipping container at a time or minimum order in 6 weeks.
That's absolutely amazing. So for those of us who are not familiar with the kind of technology that you're developing, how could you possibly ship something from Washington to Beijing in 2 hours?
We're literally bringing space travel conditions down to Earth so that everybody can enjoy them on a daily basis instead of a few lucky astronauts. We're eliminating almost all resistance associated with transportation, and we are also automating transportation.
Now, by saying that you're bringing space travel conditions on Earth, is that what you refer to by evacuated tube transport?
Yes, correct. Inside tubes, car-sized vehicles are magnetically levitated, and they operate in the friction-free travel environment inside the tubes. The vacuum is maintained with standard off-the-shelf vacuum pumps, and it is preserved by an airlock mechanism that allows the vehicles to enter the evacuated environment in the tube without letting any air in.
That's got to be one of the boldest, craziest ideas that I have heard in a long time, and I have done about 110 of these interviews so far. The first day during the Idea City conference, Naveen basically challenged everybody to come up with $1 billion ideas, and it looks like to me you've got at least $1 trillion idea there. So let's see if and how we can unpack it so that we can sort of make it a little bit more digestible for people like me and members of my audience. So first of all, what is the sort of a pipeline network that you're talking about? Can you describe it a little bit for us?
Yes, certainly. We're talking about a network of tubes like a freeway network. ET3 behaves much more like an automobile on a freeway, a limited access highway, and we use an interchange philosophy where the vehicle controls the switching instead of a switch philosophy where the train track controls the vehicles that enter the system. So ET3 can be networked together and automated so that vehicles flow through the system of tubes like packets of information flow through the internet, from origin to destination nonstop.
Wow, so what you're telling me is that you're actually thinking of implementing a number of different different types of innovation at a number of different levels to make this possible. And one of those, for example, as you just said, is to make it autonomous in the sense that the actual vehicle that travels through the pipe or the tube would be controlling the switchboard mechanisms. Is that correct?
Yes, and the occupants of those vehicles, if they're passengers instead of cargo, would be controlling the path of their vehicle. But it's automated. It's like the driverless car. You might talk to your cell phone and say where you want to go, with the Google Voice, or the Apple equivalent. And the Google's automated car, driverless car, takes you to that location. But if you change your mind, you're in control of that vehicle.
Oh yeah, just like when you change the destination on a GPS, for example, right?
Yes.
And then the GPS recalculates the best alternative route and just starts giving you directions.
Exactly. If the GPS is tied into the steering of the car, the car follows the route. It's extreme. I take my hat off to Google because it's extremely complex, the chaotic environment that we drive in. We believe that automating ET3 will be much simpler because we have a very controlled environment inside those tubes.
Absolutely, that's a great point. And actually, you might in that way be able to circumvent a number of the other issues, such as legal issues, such as insurance issues, such as controlling the environment, as you said. And in that sense, you might be able to perhaps implement a little faster than Google, because right now what I hear is some of the biggest problems or obstacles on the way are issues of insurance and basically responsibility in the case of an accident, right? Who is liable if the Google car gets into an accident? But since you have control over the route, so to speak, you might be able to circumvent most of those legal and technical issues.
Yeah, that's a very good point. We believe that using an insurability similar to an amusement park ride, where those vehicles are controlled under precisely controlled conditions, even though they seem dangerous and they seem risky, in actuality, the statistics show that the ride to the amusement park is more dangerous than the amusement park ride.
That's fascinating. I've actually haven't heard that before, but now when I think of it, it's probably absolutely true. Now, let us paint a little bit more detailed picture about the car itself, the vehicle that would be moving at such incredible speeds, and perhaps a little bit about the propulsion of it.
Yes, the vehicle is the size of a car, because let's face it, cars have won the international transportation market for moving people. So, and they also move almost all of the cargo items that are taken to the retail outlets in shipping containers. Almost all of those are brought home in cars, pickups, and SUVs. So the optimal vehicle size has already been selected by the market. So the ET3 capsule is a vehicle that will haul 4, 5, or 6 people, just like a typical car, or 1 or 2 or 3 pallets of cargo, like a typical pickup or SUV or van.
Now, when you tell me a typical car, you mean more like a limousine, right? Because from some of the graphics that I've seen, the space inside would be much better allocated, and people would be, for example, much more comfortable in their seats. They would have a little bit more room for their legs and their knees. So it will be more really like a bigger limousine sort of experience.
Yes, that's a very good point. The cubic capacity of the capsule is greater than a Cadillac or a Lincoln, or a Mercedes station wagon even. A little bit less capacity than the largest SUVs like a Suburban or a Excursion, or one of the big cargo vans. So but you're exactly right that it will be far more comfortable than most cars. You will be reclined in a what we call lazy boy sitting position. You know, like the stressless chair, or the you know, when you kick back and watch TV. That will be closer to the experience that you have in your living room as far as seating comfort. Everybody reclined and having plenty of leg room. The vehicles are actually maybe a little narrower and a little smaller in cross-sectional area than some of the larger cars, but spread out and longer. More like a Learjet or a business jet fuselage, where six executives travel in comfort. That type of environment, without the wings, of course.
Yeah, so basically what you're telling me, that by the time it takes somebody to watch the latest Hollywood blockbuster, they'll be actually able to make it without worrying about driving and traffic from Washington, D.C. to Beijing.
Correct.
What kind of propulsion system can do that?
Linear electric motors are proven to accelerate roller coasters at 4 Gs of acceleration. We're only looking at 1 G of acceleration. There are also railgun technologies that have been used to reach suborbital velocities. So in between those two proven extremes, we have identified systems that will eventually go up to 4,000 miles an hour. But I want to make it clear that that is our optimal, our ultimate vision and goal. But to make that achievable and intermediate steps to get there is really what's important. Where would we start? And we see starting with a much more moderate design speed of 600 kilometers per hour. That's about 375 miles an hour.
Yeah, when you say moderate, that's still going to be the fastest there is right now. So it's moderate compared to the final goal or the potential of the technology, but I'm not aware there's any other train right now. I think the fastest record is, what, 500 and some kilometers?
Yes.
So 600 would still be faster.
600 would be a new record. The current maglev speed record is about 363 miles an hour, 500 and
some kilometers.
550, 570, somewhere. Yeah. I don't know the exact kilometers, but less than what we're targeting.
Yes, to start.
To start with, yeah.
Yes, I wanted to make that point. So now, tell us a little bit more about the pipelines, and how do you think, or how do you plan to sustain that vacuum inside of those pipes? Because if we're talking about pipelines that span, I don't know, 7, 8, or 10,000 kilometers, how is that vacuum environment going to be sustained inside over the length of those pipes?
Yes, it's not a pure vacuum. In fact, the optimal vacuum level is what creates the lowest total energy use, and there's a lot of factors that determine that. As the vacuum level increases, the amount of energy for transportation goes down, but the amount of energy required to maintain the vacuum increases. And of course, to maintain a pure vacuum, it would take infinite amount of energy to do it. It can't be done. So the point where those two those energy requirements cross is the minimal energy use. And that's a function of how much use the system's getting, how many vehicles are going through it, because all those vehicles are going to leak a little bit. The tubes are all going to leak a little bit. But we can minimize those leaks to very, very low numbers. A typical CRT type of television set that we saw at the museum last night, lots of examples of them, really amazing.
Yes.
Those picture tubes on those CRTs are evacuated to more than 1,000 times higher quality vacuum level than required for ET3. and yet they'll have no measurable leaks. Some of those things from the 30s and 40s are still functioning.
Still operational, yes.
Still operational.
Yes.
So we can do a very good job at minimizing the amount of leaks and sealing out the air. So the total energy requirement of ET3 is about 1/50th of the most efficient electric car or electric train. And that's the energy to maintain the vacuum, the energy to supply breathable air for the passengers, oxygen supply, and removing the carbon dioxide and cycling the carbon dioxide scrubbers at the end of the trip, and also maintaining the magnetic levitation, keeping those the superconductivity temperatures at liquid nitrogen temperatures can be maintained in a vacuum much better than they can in the open environment, leading to about 1/10 of the levitation cost. Instead of a 50-cent an hour levitation cost for the HTSM prototype in China, we're looking at only maybe a 5 or 10 cent per hour cooling cost for ET3.
So now that you've mentioned all these technologies, let me ask you this. It sounds like to me that you're really not talking about any amazing breakthrough of technology, or am I correct or am I wrong?
That's absolutely correct. It is how feasible this is using off-the-shelf technologies. Pipeline production capacity exists all over the world. Now we're after, you asked about the tubes, and I have a little bit of a problem. If somebody asks me what time it is, I tell them how to build a clock. So if you bear with me a little bit, I will eventually answer the question. Tubes should be made out of a non-conductive material because there's magnetic fields on this vehicle, and when those magnetic fields move in relationship to a conductor, it can create eddy currents that cause a drag force that would tend to slow the vehicle down. And we're trying to eliminate almost all drag force and not introduce new drag force. So some of the best material that we found is a new nano-engineered form of concrete called ductile. That's the trade name. It's made for North America in Edmonton, Canada by a company named Lafarge North America, and licensed from Bouygues in France.
So the levitation technology, the construction technology, the pipe technology, the vehicle technology, you're saying that all of those technologies already exist on the market right now?
In production. All of the parts necessary to build ET3 are sitting on the shelves right now. And so what we're doing really is we're creating a brand new market for all those products, and a new market for all those companies that make those products. So that's why we've adopted an open consortium model that leverages those past investments to help bring this to reality much, much faster than past paradigm shifts in transportation.
That's absolutely fascinating. So why did no one else try to do this before if we have all the technology, all the knowledge available?
Well, there have been, in fact, that's a really perceptive question because Robert Goddard, who is famous for rockets and, really creating that whole rocketry industry that led to the moon shot, the Werner von Braun taking over, his work and developing the NASA space program with Kennedy's bold move of putting a man on the moon, and in Russia, the Sputnik that set all that into motion. So Robert Goddard started down two divergent paths. In fact, the earliest reference to travel in an evacuated environment is from 1909. When he was in school, he wrote some papers about travel in an evacuated environment. And his wife found some of those papers that lead up to maybe the early mid-20s. And at the same time, he was writing about rockets. Well, apparently his rockets generated more interest among his colleagues, and that's the path that he chose. After he passed away, his wife found those papers and received patents for them in his name after his death.
So this is the moment when I ask you, and how did you stumble into this idea? Did you happen to read those papers, or did you rediscover the idea? How did it happen for you?
Yeah, I had the same idea independently. I only found out about that after we had gone quite a ways down the path. And the first ideas I had were when I was in college. I wrote, when I was in physics lab, sometimes I would be bored when some of the other students were making measurements and stuff, and it wasn't my turn. I'd be making little drawings of mechanical stuff or whatever in the back of my, the graph paper of my physics lab book. And that was one idea that I had that just kind of gained weight over the years, and I transferred that into journals, and it was maybe about maybe 10 years after I was, working, and that I finally started crunching the numbers and got really excited about what the potential was. If the tubes are made to the optimal size, it can really bring the cost down. And so there's certain things, instead of making it like a train, if we make it much more like a car, it can dramatically lower the cost. And that's where I really started getting excited about it, and spent a couple of years researching and filed for the patents. The first patent issued in September of 1999.
So let me just get the timeline a little bit straight here. So how many years since you originally came up with the idea independently, as you said?
Early 80s.
Early 80s, so it's almost 30 years.
Yeah, yeah.
Wow.
So if you have a good idea, don't delay on it. Don't crunch those numbers right away, and either prove to yourself that it's viable or that it's not.
I see. And did you ever get any inspiration? Like, for example, people say they got the Motorola Razr engineers got inspired to make the Motorola Razr design by watching Star Trek, for example, right? Did you ever get inspired by science fiction? Because I think Jules Verne had some stories where he described, I think at the time, the late 19th, early 20th century, perhaps he was inspired by the pneumatic tubes that people used to send papers up and down in an office building.
Yes, I think so. I've seen the reference. I again found out about that considerably later, but it is very interesting that a lot of people really have had very similar ideas. And perhaps where I started thinking about ET3 was when I was maybe 4 or 5 years old. My dad was a farmer and also a physics and chemistry teacher, and he would make some of his own equipment, and he would go to a scrapyard, Winograd scrapyard in Greeley, Colorado, and he would pick out his steel, and they would weigh it out. And they had this glass pneumatic tube system with a little, it was about maybe, an inch and a half, 2 inches in diameter, much smaller than the ones that you see at the bank. Mm-hmm. Kind of the Victorian type, the real old ones. They must have taken one out somewhere and then
from a building,
from scrapping a building, and installed it to take the weight ticket, send it across the road, and then they would print up the invoice and send it back, and they would collect the money and send the money back across through this pneumatic system.
Yeah, even if you go here downtown Toronto in some of the older buildings like CIBC, their original building from the late 1800s, they do still have the pneumatic pipes, and you can see them, how they were sending documents from the top floor to the bottom floor. So I can see how somebody would ask themselves, well, why can't we put people instead of documents and send it across the world?
Exactly.
Right? And then where you're coming, where unique is that you're saying, well, if you actually create a vacuum environment in a tube, which we already have the capacity to do, and you use a sort of a mag levitation train, so you're bringing a bunch of other existing technologies, as you already pointed out, but you're creating a whole system which provides this kind of unique capability in the end.
Yes, leveraging we can stand on the backs of giants. The electrification. I mean, this wouldn't have been possible before electrification. It wouldn't have been it would have been possible for many years, but now with automation, it's far more achievable. because now we can achieve those high capacities with a small system that will cost much less than trains, much less than 4-lane freeways.
So, since you just mentioned cost, let me ask you this. How does it compare to the alternatives of, say, air, water, rail, or auto transport?
That's a good question. We think that at first it will probably be a competitive cost with super saver airfares. The lower end of airfares is where we will probably start out until the system has recovered its cost and paid off the investors. And then it will get more competitive, and the prices should fall to perhaps a tenth of the cost of flying. The operating expense is approximately 1/50th of the energy use, and maybe about the same labor savings because of a high degree of automation.
And you mean the operating cost, that includes both energy consumption and maintenance along the pipeline?
Yes. If there's very, very few moving parts and no contact between those moving parts, the few moving parts that there are, the gate valves to let the vehicles in and out of the airlock, are stationary, and they can be built for very, very long cycle life and very easy to service.
And you mentioned the investors recouping their original investment. Now, what's the kind of investment are we talking about to get this off the ground?
That's really where it gets interesting, and where we think that the return on investment is potentially very high. If we build this as an amusement ride, for the proof of concept, the demonstration, the real world demonstration of a production-ready system, the minimum necessary amount of space to do that is about 5 kilometers, 3 miles. It takes about a mile to get up to that 600 kilometer per hour speed, 375 miles an hour, and then the vehicle coasts for a mile, and then it takes a mile to slow down. Now, during the mile that the vehicle is coasting in the middle third of that 5 kilometers, the vehicle will diverge slightly, just like a car going onto an off-ramp, but only maybe about 4 inches off to the side, just a little slight shift, and then reconverge back onto the main track inside that tube. And that proves that we can do the high-speed diverge and the high-speed merge. Or the vehicle can just stay on one track, or it can go on to another track. So that proves that we can then bifurcate that line into 2 separate pathways, or converge 2 separate pathways into one. So those are all the elements of a freeway system. But with that high-speed interchange, where the vehicle selects the path of travel instead of a physical moving switch that selects the path of travel.
And in terms of numbers, how expensive is it to build that 5-kilometer track that you're describing?
If we make it with just a single tube, the capacity would be very low, only about 120 passengers per hour. But we could build that for starting at about $10 million plus the cost of the land, plus the cost of the access portals at the end. A cost of about $20 million would put in an access portal at each end and a 2-tube system. We're probably looking at, if we look at ancillary use and buildings and stuff at each end, and we're looking maybe at a $30 million investment. If we compare this, though, to, for instance, a new drug application going through the FDA, that's a minimum of $50 million and usually more like $100 million. And the time frame, instead of 2 years it's going to take to build ET3, it might be a 10-year development phase. And we believe that we have a much higher chance of survival than that new drug application that has an 86% failure rate. And we also believe that we have a much bigger market, that it will benefit far more people. The whole world is ultimately a potential customer.
That's really amazing. So how does it compare, for example, to building a highway or a water canal?
That's about 1/4 of the cost of a typical 4-lane freeway. I don't know the cost comparison on a water canal. I have not made that comparison.
I know they're massively expensive, and I would imagine much more than $30 million.
I don't know the answer. About 1/10 of the cost of elevated high-speed rail, though.
So it's 1/10 of a cost of elevated high-speed rail and 1/4 of the 4-lane highway?
Yes.
I see, and I know for a fact that water canals are much more expensive than any of these two options. So it's pretty much, it sounds like it's the cheapest way to move things around.
Yeah, and ET3, you bring up a good point with the water canal, though, because ET3 can move water in capsules. There can be capsules for moving oil, natural gas, grain,
Absolutely. So
any commodity.
that's why I was so sort of struck by the idea, because it's going to change pretty much not only transportation for people, but for goods, for services, for everything, provided that it is successful, of course. Now, let me ask you, what about when we have failure? What about when we have malfunctions? What about when, say, we have a car leaking vacuum? How do we deal or take into consideration emergency situations when something goes wrong? How devastating would it be for the passengers if it's not cargo?
Well, you asked several questions there, and they're all very critical questions to ask and to address. The safety of transportation, that's the leading cause of accidental death in most countries. For people under the age of maybe 75 or 80 years old, is automobile accidents. Over that age, it's falls. So safety is very important. ET3 promises to be orders of magnitude safer than cars. Aircraft, commercial airline flights are about 15 times safer than driving in a car. And high-speed rail is maybe 10 times safer than flying in an aircraft. ET3, our calculations show, will likely be about 1/30th of the risk of high-speed rail. Mm-hmm. So the likelihood of a vehicle stopping is minimal. I'll answer your last question, which was, what if a vehicle leaks? Mm-hmm.
My concern is people being exposed to the vacuum.
Yes, of course. And there's been a lot of horror films that indicate that a person explodes in a vacuum, which is false. We can get to that later. But people have survived total vacuum, or maybe like a 99.9% vacuum for a minute or two. Without permanent damage. It is very dangerous. Exposure to a vacuum would certainly kill the passengers if it occurred. So we need to be very careful to avoid that at all costs. So if we compare this to an aircraft, the Concorde, for instance, flew at 68,000 feet, like 18,000 meters, mm-hmm. And at that altitude, it's only 1/10 of an atmosphere pressure, 90% vacuum. Mm-hmm. So compared to sea level conditions. Occasionally aircraft do lose pressure, and a person will lose consciousness in those conditions maybe in only 20 seconds. So there have been a couple aircraft crashes caused by that. Mm-hmm. If we compare the likelihood of a failure of ET3 to a likelihood of a failure of an aircraft, a 747 has several million parts, mm-hmm. Most of them fasteners, and some of those critically stressed parts that if only one part failed, it could bring down the airplane. Very close tolerances, and the part has to be as light a weight as possible to take off. So ET3 can be designed with much more safety factor than the typical 2 or 3 factor of safety for aircraft. We are designing the capsules to a safety factor of 9 or 10, and the tubes for compressive strength a safety factor of 9 or 10. So we have much more robust structures. It doesn't have all the stress risers from all of those fasteners. We have redundant seals, and every time a capsule goes into the airlock and that gate valve closes on that airlock and the chamber is evacuated, there will be audio sensors that measure the audio profile of that capsule decompression cycle. As the pressure is reduced, it will make little cracking sounds, and it makes a cracking sound that's out of ordinary. It means that there's a potential problem with it. Also, leak detectors are very, very advanced that can test if there's the slightest leak in that capsule. If any of those seals are failed, it won't even go into the system. It won't be placed into the evacuated environment.
But what if that leak happens while you're during transportation?
If that leak happens while you're in transportation, it will also be sensed. It will leave a plume of gas coming out of it that will be sensed from the sensors inside the tube, and that capsule will be diverted. It will show that it's losing pressure, and access portals for ET3 will never be farther than 15 minutes apart.
So let's take the worst case scenario, 7.5 minutes in between 2 points. What do you do? How do you save the passengers?
The worst case scenario is there is a sudden leak and everything leaks out and all 6 aboard die. The worst case on a 747 is you lose pressure and all 400 aboard die.
I see. But wouldn't we...
So we've reduced the likelihood of that 747 that must function from very chaotic conditions of maybe 120 degrees ambient temperature in a desert environment, taking off through turbulence, through rain, through hail, flying, birds hitting it, you know, the chaotic environment of storm clouds and you know, 80 degrees below zero at altitude, and all these environmental factors that have been eliminated and controlled with ET3.
Would you install some kind of an alternative breathing system, similarly to the ones you have on the planes, for example?
It would be easy to do, or it would also be easy to, maybe it's a market for somebody that makes real nice lightweight pressure suits, for somebody that is so paranoid that they you know, pad all the fixtures in their house so they don't bump their knees. So some people are that way, and I think the market can respond to providing those types of things for people that have unreasonable fears.
Yeah, I think F-16 pilots wear pressure suits.
Yes, they're available.
Absolutely, yeah. We already have that technology too. So how does this translate for the average person? Say, let's imagine the best case scenario, your system is built. How much would it cost me? How accessible would it be in terms of pricing for the user, for the customer?
We see this going down to about 1/10 of the cost of flying. So if flying right now is about 10 cents per passenger mile, about a penny per passenger mile.
A penny per passenger mile.
So if you have a 100-mile trip, $1 to go 100 miles.
And Washington to Beijing?
About $100 round trip.
That would be incredible. Let me do the math though. I mean, Washington to Beijing is what,
8,000 miles.
8,000 miles, one way or both ways? 8,000 miles?
One way.
One way.
Yeah.
So if we're doing a penny...
That'd be $160.
$160, I thought so. All right.
I think I said less than a penny a mile. Maybe I said a penny a mile.
All right.
We can examine the tape.
Okay. So, I mean, $160 is still amazing. So I just noticed a little bit of the math there. Now, what can you tell us about the current state of development of the evacuated tube transport? Is this a pipe dream or is it a reality?
Sure, it's a pipe dream. It's a dream for a people pipe. And we think it's a very achievable dream. And we are achieving it because now there are 144 licensees in 19 countries all around the world that are bringing this to reality.
Now, before we jump into the details about how those are bringing this into reality, let me ask you something about your business model. On your website, you say that the company uses an open consortium of business model to share information resulting in cooperative benefits. Would you mind elaborating and explaining exactly how that business model works, how your consortium operates?
Certainly. The open consortium model has been used successfully in probably one of the most successful examples is the MPEG consortium that formed a couple dozen different participants, had developed individual technologies that when combined together made DVDs possible. And I think that formed in Colorado and very successful. Those individual technologies had mostly been paid for individual uses that didn't relate to DVDs at all. But when combined together, had synergistic value for all those participants of the consortium. So we are taking into consideration the fact that unlike in Henry Ford's day, everything now exists to build ET3. All the capacity already exists. Like we talked about earlier, all those parts are sitting on shelves right now, ready to be integrated in a new way that creates value for all of those stakeholders.
So you also say on your website that you have about 25 patents currently and a few more to come. If all the technology is currently available from the shelf, which area is it that your patents are in?
Right now, most of the first patent issued in September of '99, and that was kind of the more comprehensive patent for evacuated tube transport technologies. If you want to look it up, it's patent number 5950543, U.S. patent. And since then, most of the patents probably relate to the high-temperature superconductor maglev, invented by Professor Wang at Southwest Jiaotong University in Chengdu, China. And they are licensees. The Southwest Jiaotong University is a licensee.
So they're part of the consortium.
Right, that's our first institutional licensee.
Now, since you mentioned China, and you mentioned also that the fact that your patent is actually American, how is that going to work since the system is supposed to be a global system? Would you have some kind of intellectual property or ability to coordinate legally speaking? Because I know that getting a patent in China is not the same process as getting a patent in the United States.
That's correct, and we do not have a patent in China, but the Chinese are licensing our technology because we've made the patent or the license more accessible than trying to go it alone. And that's one of our strategies of intellectual property, is that we create far more value than what the cost is.
That's where the sharing and cooperative parts in that description you just read come in.
Correct.
Very cool, very cool.
So the very, very low barrier to entry. Cheaper to buy the license than to even try to do a little bit of the research that we've already done.
So, are you able to give us any more specific details about the current state of development of any of those locations or countries that you've mentioned?
Right now, we are probably the closest to getting ET3 started in California. We see California, the LA to San Francisco market, as being the heaviest air market in the United States, domestic air travel. About 6 million passengers a year are willing to spend about $120 round trip for that small time savings compared to driving. And we believe that there's at least that much market for moving of high priority cargo on that. The unique situation with California, of all the 50 states, is that they have made a commitment to the environment through AB 32 and SB 375. That's their Cap and Trade and Sustainable Communities Act that streamline the clean technologies getting into to market, and also make a commitment to bringing the carbon production levels down to 1990 levels by the year 2025. Mm-hmm. And we see that as being a driver for ET3, because ET3 can accomplish about 50 times more transportation per kilowatt hour of electrical energy or per unit of carbon production. So if per unit of carbon production, if we can provide 50 times more transportation, that's incentive to make investments into ET3 in California.
That's like taking 49 out of 50 cars out there.
Yes,
more or less,
and those being Toyota Priuses, the best cars,
the best possible. Yes, absolutely.
Maybe 200 or 300 typical cars.
Absolutely, that's outstanding. So, could you give us any potential or actual timeline on that project?
We believe that we will break ground and select from the several options that we have available there now towards the end of this year. And that construction will take a couple years. The
Mm-hmm.
planning and construction.
Mm-hmm. And who are your major partners that you're working with at the state level, I imagine?
Yes, I would like to be able to tell you that when we've made that final selection.
I see. Okay. Let's go to at the international level. Are you able to give us some more specifics at the international level?
Yes, we have a licensee in Canada, in Calgary, as a matter of fact, that is proposing a route from Calgary to Edmonton and up to Fort McMurray to move oil and people. One of the problems, I guess, up there in the oil field is the ability to attract employees.
And by the way, that highway, the auto highway between those two cities, is the most dangerous highway in Canada, with the highest density of fatalities. So
I think weather is probably a contributing factor.
Weather, there's lots of trucks because of the oil fields. There's lots of trucks. People get road rage and try to pass them, in all kinds of situations, and quite often you have very serious head-on collisions with, pretty much everybody dead after such a head-on collision. So I can see how that would be a perfect place to build such a transportation connection. Anything else? Anywhere else?
Well, of course, China. There are several licensees in China, and the Chinese invented a new form of magnetic levitation, high-temperature superconductor maglev, that ET3 uses. So those are Southwest Jiao Tong University is associated with that. Also, Colorado School of Mines is developed a strong interest in ET3. Now we're into the third year with their EPICS program. Jack Panter, a licensee in Colorado who's a retired Navy fighter pilot and 747 pilot, started that program out at Colorado School of Mines, where now over a dozen teams of students have done work on ET3 projects.
Mm-hmm, mm-hmm. Now let's zoom out again and think about the really big picture here from the point of view of your consortium. Can you give us some large timeline, benchmark goals, if you will? Let's say about the midterm, short to midterm, 5 to 10 years, and perhaps the long term, say 20 or more years. How do you see that coming into existence?
We see ET3 displacing cars and aircraft much faster than cars and aircraft displace trains. Henry Ford introduced the Model T in 1907, and roughly 35 years later, automobiles were close to 90% market share. Mm-hmm. So, from 1% market share to 90% market share in roughly 35 years we look at those S curves now, they're much steeper. The adoption rate for the internet and for cell phones, each one of those lines is getting more vertical as the synergies build with all this capacity that we now have, and the ability to use parallel processes instead of having to go through those serial processes. So we believe that the most significant barriers are not technical barriers or production barriers, they're political barriers.
And legal
and
like
those are hard to predict, exactly when that resistance will yield.
So the obstacles are not technical or technological, they're not scientific, they're really political.
Yes. We've been thrown under the train a couple times, and hasn't killed us yet.
Yes, I'm very happy to see that too, by the way. So let me ask you this question then. Are there any fundamental misperceptions, misrepresentations, or confusion about your idea, evacuated tube transportation, that really bug you and that you want to clear out?
Yes, there's a common misconception, and it naturally occurs that a lot of people are dismissive of ET3, thinking it's the pneumatic system, and especially the smartest people that know that technology can't scale because of all the air friction on the entire inside surface of that tube would be astronomical. It takes an astronomical amount of power. In fact, it was tried back in the 1880s, 1890s by the editor of the Scientific American, Alfred Beach. Built one under the streets of New York City. And just to go a few blocks with a van-sized vehicle, it took a 400 horsepower motor to move it just a few miles an hour. So that technology really doesn't scale real well from the little Victorian tubes. So that's one common misconception about ET3. ET3, the tubes are evacuated and we use linear electric motors to power it. The other misconception is a lot of people call ET3 a train. And it is much more like an automobile on a freeway in the design philosophy and the operating philosophy and the user experience, compared not to be compared with a train.
Now let me clarify something for myself though. Do you need, say, if you want to go from Toronto to Washington, do you need 2 tubes? Or do you need 1? I would imagine just like with trains that require 2 tracks, 1 for each direction, the same would apply for the tubes, right? 2, 1 for each
Yes, just like most roadways are two-way roads.
2-lane.
Occasionally there are 1-lane roads that meet special circumstance in limited areas, and it's likely that the same will be for ET3. That there's some situations where a single one-way tube might serve a useful purpose.
Very well. I think we spent about 15 minutes discussing many of the details surrounding the technology, and I hope that helps people understand the viability of it and the fact that we're not talking about really rocket science here or anything up into the future, 10 or 20 years. We're talking about off-the-shelf stuff that's available now. But let me ask you a couple of even bigger picture questions here. There's a range of opinion about this century that ranges from gloom and doom to great optimism. So I want to ask, where on that scale do you fall?
We're pragmatic optimists.
Because you mentioned you've been thrown out under the train a couple of times. It hasn't killed you. So to keep going, clearly you have to be optimists. But
yes. Pragmatically speaking, we recognize that it's very difficult to establish a new order of things. Like Machiavelli observed in the year 1513 when he wrote The Prince. The innovator is the one that has all the knife wounds in his back. The status quo usually attacks what they perceive as a threat, even though we believe that ultimately the status quo will profit greatly from the adoption of ET3, and we can show why. But that's not the typical response. The typical response is to see something as a threat instead of an opportunity.
And that's precisely my point, because most of those companies or industry that would be terribly disrupted by this kind of innovation would be thinking short to mid-term. The benefits that you're talking about are probably much longer term, but in the shorter term, they actually may try to kill the project by exerting, for example, political or legal influence.
Yeah, well let's look at just one example, which is a lot of people make the assumption that the air industry might be against us. And I could see that some air executives might see this as a potential threat to their business. The way we see this unfolding, though, is that the likely market for ET3 will start out in that 200 to 600 mile range, 300 kilometers to 1,000 kilometer range, where it's too far to drive but not far enough to fly. Where ET3 then would displace the feeder routes that cost the airlines money, and but allow them to make more profits on their overseas routes and long distance, long haul routes that are much more profitable.
Just like you mentioned the case in California, for example.
Yes, and you know, doing those regional routes that you know have a lot of fuel cost and a lot of labor cost for the airline industry, but support their international routes where they make the money back. We think that we will actually boost air profits to start with very quickly, but then ultimately, what ET3 offers is, if ET3 is implemented in developing countries like Africa and India and Asia to a great extent, bringing up the standard of living so a lot more people can afford to fly, even in North America, where Americans fly more than most other countries. And air travel is only 7% to 10% of the passenger miles of travel. Most Americans cannot afford, 2/3 of Americans can't afford to fly more than once per year. Half of those, 1/3 of Americans have never been in an airplane of any kind. So if we take those statistics into account, there's plenty of room for growth in the air industry worldwide if we can bring up the standard of living so a lot more people can afford to go on vacation just once per year.
You know, I lived in America for a year, and a couple of things that shocked me was that, for example, when I was in Fort Lauderdale, I had some of my colleagues who'd never been out of the state of Florida. When I was in West Virginia, I had friends who had never seen the ocean. And it's probably, I don't know, 7 or 8 hours worth of driving. And it really struck me. It really amazed me.
It's amazing. Brenda and I, when we were doing some of our looking for real estate in Florida, we were looking at some of the more rural areas, and there was a young lady working in the government office, and she had worked there as an intern while she was in high school, and now she had a permanent job there, and she had only been out of the county one time.
Unbelievable.
She was like in her 20s.
And that's the 21st century.
Yeah, amazing.
So you want to change that with...
Well, we think it's far more powerful to build bridges between cultures and where we can develop friendships and understanding than to try to build barriers and walls.
And actually sharing the knowledge and sharing sort of the effort across borders and globally, because that's obviously going to require global network.
Yes.
The process of building the network would also create the conditions for that kind of bridging the gaps, bridging the differences.
You're hitting on the most important thing with ET3.
Because that creates the socialization between cultures.
Yes. And also it has a very practical need also, because only if ET3 is built to the same standard, the same tube diameter in every country, can it eventually be networked together with that global backbone that achieves our global vision. So it's really everybody's in this together. So what makes the sense to make that tube the optimal size such that if it were an inch or two bigger than optimal size, it fails to achieve maximum global penetration, maximal transportation of goods and people, because it's slightly too expensive for most people. If it's an inch or two too small, it fails to achieve maximum market share because it can't achieve utility to move things like stoves and refrigerators and big TVs and things and sheets of plywood and things like that.
Yeah.
Or it might be not as comfortable as it could be if it, might be a little bit too cramped and people wouldn't want to ride in it because of that. So that optimal size is the most important thing, because only if it's built to the same size in every country can it eventually be networked together to achieve that global vision for everybody's benefit.
Absolutely. That's another of the main reasons why I love this so much. Now, Daryl, time is advancing here, and while I'm enjoying our conversation very much, I think I have another 2 or 3 questions that I would like to close on. So first, let me ask you a bit of a broader question. The name of my show is called Singularity One-on-One, so I want to ask you, what's your take on the technological singularity? Are you familiar with it?
Yes, the convergence around 2045 or so of transhumanism and the computing power growing exponentially, and our ability to use that to increase our well-being. And it's inevitable. Technology has improved the well-being of humans for thousands of years, since we first strapped shoe leather on our feet.
Or since we
first
adopted
transportation
the usage of fire.
Yes.
Ever since, because that allowed us to mold our environment pretty much. Then the second last question is, where can people find more about you and your work? Because it's really fascinating. And of course, I plan to actually post a number of very cool videos that I found on your website along this interview. But what's the best place to begin?
ET3.com and ET3.net.
Fantastic. So, Daryl, the last question that I always ask of my guests is always the same, and it is, if people were to take a single sentence or a single message from our 1-hour conversation here today, what would you like that to be?
Get involved.
Get involved.
Yes. It's an open consortium, and everybody has something that can be of value to ET3. And it ultimately, everybody in the world benefits.
Daryl Oster, thank you so much for being with us today.
Singularity.